Hello, everyone. Welcome you all to my talk Smoke Signals, a journey towards environment reliability. My name is Ashok. I'm an engineering leader with TransUnion, and I've been associated with the quality assurance and engineering domain for close to 2 decades now. Within testing, my area of interest is around test strategy, leadership, automation, customer advocacy, and test data. Outside of work, I'm also a blogger. I blog in external platforms. I speak in multiple different conferences, both internationally and local events that happen within India. And I'm also passionate about mentoring young test engineers who are new to the testing field. In the next couple of minutes, I will be talking through our team's journey of building efficient smoke testing frameworks and some of the common pitfalls that teams typically tend to fall into when they embark on this journey of setting up a smoke testing process and framework. I'll also talk about some of the key success metrics that we as a team had when we implemented this sort of a smoke testing framework, and also give you a sneak peek of what's in store for us as teams in the future with regards to smoke testing. The need for smoke testing as a process or as a technique, I wanted to talk about this need from two different perspectives. One is the perspective of the industry, which is basically the perspective of all of those analysts who research the software testing field and publish their findings. I wanted to call out key findings from some of these analysts. The first one being Gartner. A study by Gartner reveals that nearly 25% of test execution time is wasted for teams because they're waiting for their test environments to be available to them. And there is also another study published by Forrester, which indicates that 50% of test environments is not available to the teams when they start their testing. A study by Capgemini also reveals that of all of those defects that teams report during their test execution life cycle, 60% of those defects are related to environmental issues. So these are defects that could have ideally been reported much earlier in the life cycle if there is a smoke testing process implemented for those teams. Again, another study by Capgemini also indicates that 80% of the teams that have had success with their test automation also had stable test environments with them. So the success of automation is directly related to their environment stability itself. So now that we have spoken about what industry analysts think and predict about the environment stability and the need for smoke testing itself, I also wanted to talk about an insider's perspective, which is the perspective of teams like us, and what do we as teams think as objectives for implementing a smoke testing process. Now, the key objective that we wanted to achieve is we wanted mechanisms to monitor our environment stability, and we wanted to identify issues much earlier when they were occurring in our environment so that they can be fixed earlier as well. Also, what we noticed was um, when the environments go down, it ideally wastes their testers' time, because when the testers start with their test execution lifecycle and then they notice that certain applications within the environment are not available to them for testing, their test timelines are now getting extended, and the capacity that was allocated for testing is now becoming idle. So we wanted mechanisms to avoid this and to manage our testing capacity much more efficiently. Also, what we noticed was as we matured into our agile implementations, our developers wanted to check in code much more frequently into our environments. While frequent code check-ins uh, uh, is definitely a good to have in an agile implementation, a negative effect of code being checked into environments frequently is the tendency for applications to get or become unstable within the environment. And as code check-ins happen and frequently, and the environment also goes down frequently, it resulted in our developers' confidence levels going down, and they tended to pull back from their frequent code check-in processes itself. We wanted to have our smoke testing process as a safety net that allows our developers to be able to frequently check in code into our environments, and also enable continuous feedback cycle that is far more rapid for them to immediately get feedback of how the environment is after they have checked in their code into it. So this is a reference architecture that I have put together based on my experience working with multiple teams and organizations in the smoke testing realm itself. Now, in this particular reference implementation, we've had Jenkins as our CI tool, but you could replace this with any of your existing CI tools. The lower part of the architecture is where I've shown all of the individual applications that need to be smoke tested, and the scripts for each of these smoke test uh, applications are linked into our CI pipeline, which is configured on top of Jenkins. And the scripts are executed on a scheduled basis. And the Jenkins master node is also configured to multiple Jenkins agents. So we didn't want to have a single Jenkins agent, but we wanted to have multiple Jenkins agents. And we wanted to also ensure that our agents are across different OS platforms as well, because our applications are built on different operating systems. Now, the parallelism at the agent level ensured that we would be able to spawn our scripts parallelly across multiple different agents. And we also had this agent monitoring scripts that will monitor the health of each of these agents, and will alert us immediately when an agent goes down. We also had auto recovery scripts configured that will have the capability to bring these agents back up to running state if they go down during the course of the smoke test execution itself. Within the agents, we also configured multiple executors. So the parallelism is achieved at the agent level and also within the agents also. So this sort of a parallel execution at multiple different layers helped us to speed up the overall smoke execution time. And that was a key factor of enabling that rapid continuous feedback cycle that we were able to provide to our developers when they actually check in code into the environment. Now, some of the common pitfalls that I have seen teams get into when they start thinking about implementing a smoke testing framework is that they start off with building very bloated checks. Now, by bloated, I mean checks that are huge, that checks that are not atomic, checks that try and test multiple things within an application. The goal of a smoke test or a smoke check is to smoke an application, just to smoke an application to see if it is still up and running or not. So the bloated checks is actually a problem that we need to avoid and try and make our checks a lot more leaner and meaner. The other pitfall that I've seen teams get into is their tendency to try and automate everything under the umbrella of smoke testing. What I've typically seen teams go through is that they try and combine their or they try and make their smoke test an all-in-one test, wherein the smoke test is also a regression test, it's also a functional test, it's also a performance test, which we should be avoiding, and we should be clearly decoupling what needs to be included in a smoke check. And that is basically the reason of why we need to move away from this automate everything mindset. The other problems that I've seen is the balance between what needs to be checked or tested at the UI level and what needs to be tested at the API and service level. Now, when we have our smoke checks more towards the UI side, then our checks tend to become a lot more heavyweight, and it also results in slowing down the overall test execution pipeline. So we need to have the right balance of what needs to be tested at the UI level and what needs to be tested or what can be tested at the API database or the service layer. And we need to prioritize towards or move towards a more API and the service layer check rather than a UI check for smoke test, because we wanted to enable that rapid automated continuous feedback for our developers. The other tendency that I've seen teams go through is when they start off with smoke testing, they start off by building a very complicated framework with all of the features, bells and whistles, which need not be the case for smoke testing or any framework itself. So what we need to do is try and reuse our existing frameworks. What we did in our case is we did not create a centralized smoke testing framework, but what we did was we tried and reused whatever frameworks that existed for our functional and regression testing, and try to optimize the checks that run on top of these frameworks. While we did not invest on the framework itself, we invested a lot of effort and time on what needs to be smoke tested or at what level we need to smoke test. So we moved away from over engineering our frameworks by simplifying and reusing what was existing already in our ecosystem. The other pitfall that I wanted to talk about is the urge for teams to focus more on coverage rather than speed. In a testing technique like smoke, what is more important or what needs to be prioritized more is the speed of the test rather than the coverage of the test. So we need to ensure that we have multiple atomic checks that can quickly run in the environment, smoke the environment, and give us feedback if the applications within the environment are still hanging together. So that should have been our priority rather than trying to check everything in the environment. So that checking everything mindset is leading to this inclination towards increasing the coverage more and more, because the coverage would anyway be taken care of in the subsequent phases of testing, which can be your functional testing, it can be your regression automation, it can be your performance or load testing strategy and all of that. But what is key to a smoke test architecture is the speed, and we need to consistently optimize for speed. So some of the key success metrics that we as teams noticed after we implemented our smoke testing is that we were able to smoke test 21 applications within our environment, and we had included 40 atomic checks that run across these 21 applications. We achieved an overall runtime of 9 minutes of execution across all three environments, SIT, UAT, and prod. And we have so far identified 33 defects. These are defects that are environmental problems that could have been reported by teams after they would have started their testing lifecycle if we would not have had this sort of a smoke testing process in place. And this would have actually resulted in teams wasting their time or wasting the test execution lifecycle itself. Now, looking into the future, we want to consistently optimize for speed, and how we do that is we will continue to include atomic checks, remove bloated checks from our smoke testing suites. We will optimize and tweak our existing smoke testing architecture uh, to increase the speed of execution itself, so that we were able to provide that rapid continuous feedback. We're also implementing a centralized reporting dashboard on top of Grafana, whereby we can push all of these smoke testing logs into a centralized dashboard for much more insightful reporting. We're also thinking about doing a implementation on top of machine learning models, whereby the logs that we have collected over the past smoke testing executions, those can be used to gather insightful data about which of the applications in the environment can most probably go down for a specific check-in. So we wanted to see if our past experience with smoke test executions and the logs and data that we have collected, when fed into a machine learning model, can give this sort of a prediction to us. So the developers can actually be preempted about their change even before the change is actually implemented into the or checked into our environments. So these are some of the exciting things that we want to work towards, and I hope I'm able to talk about all of these in more detail in the next year's Testflix conference as well. So thank you all. Thank you for your time.